Hey everybody, hope you're doing well. It's Dr. D. It's been a while since I've talked at all about regression, so I wanted to brush up on my regression skills and talk to you guys a little bit about something that seems to be pretty popular. People seem pretty interested in this. So what we're going to do today, we're going to do an example of multiple regression with dummy variables. Not sure why. If you guys would post in the comments why this seems to be so popular, I'd love to know, but this seems to be really popular. Maybe it's just because it comes up a lot, and it does come up a lot. Dummy variables are really useful. So just a quick recap with multiple regression. When we use multiple regression, we have a linear model usually. Although we can vary that, we can use a more complicated model. And we have some variable y that we're interested in, and we think that it is constructed by a linear combination of some variables x that are modified by these coefficients. So b2 x2 plus dot 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 plus beta k xk. And then we have some error term, right, that creates noise. It makes this look like the real world looks, right? So these betas, these are our coefficients. This one's the intercept, and then all of the rest of these are, they're multipliers that affect the influence of x1 on y, right? And this is really useful and powerful because if we take the derivative of y with respect to x1, beta 1 is what, d1 dy dx1 equals beta 1. Which, if you took calculus, you'll remember that. If you haven't taken calculus in a long time, might not. But that's the slope term for x1, right? That's the effect that x1 has. And we can do some other stuff with derivatives to try to understand the influence of x on y. But when we have dummy variables, these are going to be these can be categorical variables, and that's what makes dummy variables so powerful, right? Is that we can treat them, instead of treating them like quantitative variables that get larger or smaller on a continuum, they're just like switches that we flip on and off again. So before I get more into the theory side of it, let me pull up the data that I generated. This is fake data, just to give you a heads up, so I'm not selling company secrets or anything, but it's website data that I generated, right? So we have visitors to a website, and we have the duration of their visit in seconds, and I made up numbers that I thought seemed reasonable using a process that maybe I'll outline in another video. And then we had them fill out a survey, for example, that tells us their gender, the browser that they're using. We can pull this directly from their visit a lot of times. In addition, whether they're browsing with a mobile browser or not, and then how many years of education they have. I just wanted to pick a few variables that might be useful and interesting in determining the duration of a visitor. Age might also be interesting. I just didn't want to make it too complicated. And the first thing we can do is we can just say, okay, well, is the duration of a visit, and this will not require dummy variables, but we can say, is the duration of a visit related to the years of education? So let me keep this window open maybe so we can see it as we go along. So let's just say we want to let x1 be years of education. And we just think that the amount of browsing time depends on the years of education, and so we're going to let y equal our duration, the duration of the visit. Well, then once we've done that, we can build a model, right? The model is that y is going to be an intercept plus the influence of years of education plus some error term. Okay. Now that's the model in the population. These are Greek betas, right? And that's what we really want to know. We really want to know, maybe we want to know the intercept, but usually we want to know what this value is. We can't know what that value is, though. So what we can do is we can build an estimated model, or an linear regression equation, which is going to be the expected value of y equals beta 0 plus beta 1 x1. And then we can estimate this within our sample, right? So when we estimate this, we'll get y hat equals b0 plus b1 x1, and we go from Greek to Roman because at this point we are looking at our sample. We're not looking at a population, so we're using our Roman letters here. So I we want to estimate this, right? Now, the way that we do this for linear equations, we could technically do it manually, but it's not super easy. So the way that I'm going to do it is I'm going to go back to our website data, and I'm going to use our data analysis tool pack, which if you haven't installed it and you don't have it, it's really powerful. It's free, I believe, if you have Excel already. So I highly recommend installing it. I'll show you where it is. It's in the data tab. If you click on data analysis, that'll give you a bunch of stuff here. Usually I think it starts out selected something else, but regression is one that I use frequently. So that's highlighted because I was just using it a minute ago. And normally these will not be filled in at all, but since I've been playing with this a little bit, these are all filled in. So let me get it back to what it looks like when you'll see it. So first we have to choose our y range. That's where our left-hand side variable is, right? Dependent variable. And in this case, I want to select this whole column. You can see that I have 10,000 observations. So that's a pretty big data set. I do have labels, right? That first one has the label in it. And now I want to put my x's in. In this case, I only have one x. So all I need is this years of education column. When I click that, now I want to put this in a new worksheet. And what I'll do is I'll call this duration equals, it won't let me do equals, I think, so I'll just use a dash, education. Okay, so that'll give me a new regression output table. I have a whole video on how to read regression output tables, but just so we can take a look at this, actually I just need this left half. Over here we have the R squared that says that 11% of the variation in duration can be accounted for just by the years of schooling. So that accounts for some of this stuff. And then down here we have a p-value. That's on the intercept. Here we have years of education. Our p-value here is 1.6 times 10 to the negative 262nd. That's very unlikely. And that, if you recall, is it's a p-value on the hypothesis that beta 0 is equal to, or beta 1 is equal to 0. And with that very low p-value, we can reject that. Clearly, beta 1 does not equal 0. It's a very low standard error. It looks like, right here it says that our estimate, B1, equals 10.39, roughly 386, I guess. What that says is for every year of schooling, the person's website visit is 10 seconds longer. Now, there's a fair bit of variation, but at the same time, with 10,000 data points, we can pretty precisely estimate that. So 10.386 is our guess. And so that's a very simple model, and we've done a good job of it. But what if we want to know about browsers, right? What if we want to know if different people using different browsers have different visit times, right? Well, one thing we can do is what we want to do then is we want to multiply a number by our browser, but we can't, right? Because you can't multiply a number by Internet Explorer. It doesn't mean anything. So what we usually do, in this case, I have 4 possibilities built in here. One is Internet Explorer. One is Chrome. One is Safari. And one is Firefox. And so those are the 4 options that I have. I could put an other one or whatever. Just to make up the data, I figured to choose these 4. And what we want to do then is we want to basically separate our data into 4 subsets. That's the way we do this, and we can build these dummy variables such that it equals 1 if our user is using Internet Explorer, and equals 0 otherwise. And so let's define this as D1, right? That's equals 1. In this case, we'll define this one as D2, this one is D3, and then we always want to have one category omitted. And so in this case, I'm going to omit Firefox, meaning that they will all equal 0 if we're not using, or if they're using Firefox. The reason is that we don't want them always to add up to 1, or else it'll interfere with our intercept term. So we can define the dummies this way. I have another video on kind of the theory of dummy variables, so you can feel free to take a look at that. But this is how we will use our dummy variables. So in Excel, the easy way to do this is to copy your category name right there. So I have Internet Explorer, I have Chrome, and then I have Safari. And what I want to do is wherever this is equal to Internet Explorer, I want a 1, and wherever it's not equal to Internet Explorer, I want a 0. So if I do equals if, now I have C2 equals F1, then 1, otherwise 0. Now that formula works for right there, but I want to be able to use it over and over again, right? And so I want to keep my browser column locked, so I'm going to put a $sign there to convert that to an absolute reference. And in this case, I want to keep my first column or first row locked. That way, when the browser column locked means that it'll slide down, right? That's a lock to this column, but it'll slide up and down the rows. And over here, keeping this row locked means that it'll slide across. The comparison will slide across, but it won't go up and down. So if I fill these down, you can see that wherever it's equal to Internet Explorer, it's a 1. Everywhere else, it's a 0. And then if I copy these to the right, you can see that now it's doing that for Chrome as well. And then for Safari over here. And Firefox, again, is an omitted variable. So wherever we see Firefox, and for some reason the formula I used made that unlikely, 0, 0, 0, right? Those are all zeros, which is what we want. Okay, so now let's see. Let's build a more complicated model. Let's say we want to know how duration of visit, y, depends on not only education, right, which we can still include in this model, that's x1, but also our dummy variables, b2 d1, beta 3 d2, plus beta 4 d3, plus epsilon. So now this is a larger model and a more complicated model. Take the expected value again to get rid of that epsilon, and then we can get our estimated regression equation. Y hat equals b0 plus b1 x1 plus b2 d1 plus b3 d2 plus b4 d3. Okay, so we have all of these in our model. What we now want is estimates for all of these, right? We want estimates for all of the b's across here. So the interpretation of them is going to be somewhat straightforward, particularly for this one. That's a slope term. But now for our dummies, the way that this model is set up, we have an offset, right? So this is our intercept, right? And now when d1 is equal to 1, meaning that our user is using Internet Explorer, then these are going to both be equal to 0, right? So with IE, this will be equal to 1, and these will both be equal to 0. But this is going to be equal to 1, which means that it's just going to shift for every user by this b2 amount, right? And so in essence, we have a different Internet Explorer intercept, right? The intercept for Internet Explorer is going to be y hat equals b0 plus b2, and then we're going to have plus b1 x1, right? And so that's our estimated regression equation, given that we know the person is using Internet Explorer. Alternatively, if we have somebody who we know is using Chrome, then this is going to be 0, and this is going to be 1, and this is going to be 0, and so their y hat is going to be b0 plus b3, sorry, that is equals b3 plus b1 x1. So this slope stays the same across different users, right? But now we are offsetting by different amounts, right? And so the same thing for the intercept for Safari is going to be b0 plus b4, and then for Firefox, the intercept is just going to be b0. So you can think of the b2, b3, b4 as sort of the bonus amount of time, positive or negative, that a visitor spends on our site if they're using Internet Explorer instead of Firefox, right? Okay, now we can estimate this equation just by telling Excel that we now have these dummy variables as our x's. So now we're going to do data analysis again. Regression. Our y's stay the same, but now our x's are a little bit different. In addition to years of education, we now want to include our 3 dummy variables. Okay, so now we have this entire subset of data as our regressors, as our regressor data. So now I have duration is a function of education and browser. I click OK, and here you can see my r-squared still 11%. Not sure that was really super useful. And sure enough, when we look at the p-values, none of these seem to be statistically significant. Now, that's not to say that we don't have point estimates. In our data, it looks like Safari users, on average, used our browser about 4.5 seconds longer than Firefox users, while Chrome users used it about 1.3 seconds longer than Firefox users. But those are not so far away from 0 that we can say that they're statistically significantly different from 0. Okay. Let's look at another dummy variable. In our website data, we also have gender, right? So let's define a new variable. We'll call it let's call it female, and this is going to be equal to, if this equals f, then it's 1. Otherwise, it's 0. Okay. So now we have another dummy variable. This one's a simpler dummy. It's just true or false, right? We only need 1 in this case. And so in our model, we can just define this as, maybe we can call this d sub f because it's a female dummy. Maybe we can even refer to the rest of them as d sub IE, d sub Chrome, and d sub Safari. That will allow us to kind of read it a little more easily. And now we have an even bigger model. Beta 0 plus beta 1 times years of education. I'll just call that x1 again. Plus beta 2 times Internet Explorer. Plus beta 3 times Chrome. Plus beta 4 times Safari. Plus beta 5 times female. Plus epsilon. Right? And so this is an even bigger model. This is a y, by the way. We can estimate this. Again, we'll go through the same process, turn these into b's, and now we're trying to find an estimate of the b's to see if gender makes a statistically significant difference on the duration that people spend. So let's go to data analysis, regression. Just turn this to I, and that should cover our entire data set. Now we have duration as a function of education, browser, and female. Click OK. Takes a minute, but there we go. What do we have here? Well, now we have an intercept. Years of education still pretty stable at 10.36, 214. Not a lot of movement here. Now we see that female actually has a significant difference, right? That's positive. What that means is that females, on average, spend 8.8, controlling for years of education and browser, right? Spend 8.79 seconds longer on the site than men do. And that's significantly different from 0 at any level of significance, right? That p-value is very, very low. So we can say that females seem to like our website more than males do. All right, now the last thing, I wanted to show you a couple things we can do with interactions. So let me move up again. Let's see. Okay, let's work with some interactions here. Let's say maybe we can simplify our model a little bit. Maybe not. Maybe we'll do a really complicated model first. Let's say that instead of Internet Explorer, Chrome, and Safari, we want to interact those with education. Let's say, why would we want to do this? Maybe we think that instead of there being a data structure that looks like this, a slope for where this is our education, and this is our browser, or our duration, right? Our duration of browsing. The model we built looks like this. We have 3 parallel lines or 4 parallel lines based on browser usage, but the slopes are the same regardless of which browser they're using, right? The relationship between duration and education is the same. Now, another way to look at this might be to say maybe the intercepts are the same, right? But the slopes are different, right? So maybe they start at the same place, but if you have high education and you use Explorer, then that education will really drive up your amount of browsing. Alternatively, we might say that Safari, it grows at a slower level, and then in some other, maybe Firefox, if you use Firefox, the more education you use, you have the lower your duration of visit. This relationship is the one we modeled, and this is the one that you model where you just have your dummies kind of added linearly. We can also model this third one, or this other one. This one is modeled as an interaction effect, where we still have an intercept term, but now instead of beta 1 times, we can still have beta 1 times x1. That'll be for Firefox. Now instead of beta 2 times our Internet Explorer dummy, we're going to have our Internet Explorer dummy times our x1, our education. And then we'll have beta 3 times our dummy for Chrome times our education. And then beta 4 times our dummy for Safari times our education. Right? And the effect that this has is that now, let's say we know that DIE equals 1. We know that we have an Internet Explorer user. What is the effect of x on, or sorry, that should be 1. What is the effect of x on y? Well, the intercept is still the same, or is beta 0 now. So that's being held constant for everybody, right? It's beta 0 right here. But the derivative of y with respect to x1 depends on beta, right? And on the dummies. In this case, if we know that DIE equals 1, then it's going to be beta 1 plus beta 2. Because it's beta 1 plus beta 2 times your dummy, right? Alternatively, the slope term for Chrome users is going to be beta 1 plus beta 3. And so now we are allowing this slope to adjust. How do we do this? Well, instead of using our x's here, let's create kind of a new data, just years. Let's call this educ. So I want this to be years of education. And I want to copy that all the way down, and that's just the same variable. Excel requires you to use rectangular regressor shapes, rectangles, matrices, arrays. So I'm going to stick with that. Now we're going to do educ cross IE. It's going to be this. We'll stick with $K2. Oops. $K2 times IE, Internet Explorer. And then we have educ x Chrome, and then educ x Safari. And those will be 0 everywhere. But now you can see that instead of having a dummy variable, which is just ones or zeros, I have a variable that takes the value of education or takes the value of 0. Now when I do a regression, it's going to estimate this, something that looks like this. I think the way that I construct the data, this should show no real strong relationship either, but we can see. So now these, I don't have gender in my model again this time, but I do have something like this. So let's go with this, enter. And then we'll call this education browse cross educ. There we go. Click OK. Takes a minute. Yeah, none of these are statistically significant, but you can see these terms are very different. Education term is still the same, but now education, these interactions tell us that for every year of education, Safari users use it for 0.34 seconds longer than Firefox users. So that's how the slopes differ, not by very much, not enough to conclude that they're different from 0. What if we do, instead of a browser interaction, let's do a gender interaction. So let's do educ cross female. And let's steer clear of the browsers. Let's just do the simple model here. Regression. Now I'm going to take these two, and now this is female cross education. Click OK. This is statistically significantly different from 0. And before, where we saw that women, what did women do? They browsed at 8 seconds longer. Here we see that actually this, in this model, it has to do with their education level, right? So it's 0.66 seconds per year of education, in addition to more than men. Now we can include the full interaction model. And so this model, just to give you kind of an idea of what it's doing for men and women, we had the two models, one of which looked at a relationship that had the same slope but different intercepts, and then this one has the same intercept but different slopes, right? And so in this case, females, their browsing increases faster with respect to education than males. And so what we can do finally is we can do a full interaction model where we allow these to basically just be two different lines that have different functions. The way we do this is by including both a dummy term and an intercept term, right? So beta 0 plus beta 1 x1 plus beta 2 d female plus beta 3 d female times x1. And now you can see that if we have somebody who's a male, both of these will be 0, right? And so it's just this simple regression. But if we have somebody who's a female, both of these are equal to 1, or this is equal to 1 and this is equal to 1, and then this one becomes equal to education, which means that for females we are actually estimating a totally different equation, which is basically, to put groups together, beta 0 plus beta 2, that's our intercept, plus, and then distributing, beta 1 plus beta 3 times x1. And so we have you can think of beta 2 as the intercept modification for females, and beta 3 as the slope modification for females. So let's build that structure into this data. The easy way to do that, one easy way to do that, is just to insert here and then set this equal to the one over here. So now you can see that we have a dummy variable as well as an interaction variable. Data analysis, regression. Now this data, we want it to go from here to here and then all the way down. And this is going to be education, female cross education. Click OK. And here we see that it looks like it's the education that seems to be driving it. Females, this is not significant. Education is still significant, right? So 9.56 seconds per year of education for men, right? Because that's what that is. And for women, it's going to be, that turns into like 11 seconds per female, right? 9.5 times per year of education. And that's significant at the 2% level, anything above the 1% level, really. But now the female intercept difference is not statistically significant. Women on average, controlling for the interaction effect of education, look at this website for 12 seconds shorter, but that there's too much dispersion around that to really be confident about that measurement. We can build one more model, maybe build the big model. We have a lot of observations here, so there's a lot we can do. We didn't include mobility at all. Do we want to include that? I don't know. Let's see. So here we have years of education, internet, Chrome, Safari, female, full interactions, the kitchen sink model. Let's do education cross mobile, because mobile is built in here already as a dummy variable. Let's do education cross female. Maybe let's do education cross browsers first. Chrome. Where is it? Yeah, E2, yes. Safari. And then female. And this is going to be a really big model, but it should give us all the full interactions. There we go. Education cross female, education cross Chrome, education cross Safari, mobile. There we go. Okay, so data analysis, regression. We have our same inputs. Now our x's are going to be starting with mobile all the way across to all of the interactions and all of the dummies and we now can call this the duration equals everything. Click OK. It's going to take a minute because that's kind of a long regression, but we can see here that what do we have? All sorts of stuff. So years of education are significant. Mobile device, that kind of matters maybe. Education cross mobile does seem to matter. For every year of education, mobile users use this for 3 seconds less. Education cross female also seems to matter. So we have 2 interaction effects going on here. Yeah, so this is how you use dummy variables. Clearly there's a lot you can do. You could introduce nonlinearities if you really wanted to, right? You can do that pretty easily by squaring things or by recentering them. The R squared on this is still not great, right? We only explained 18% even at the best. So maybe we need to collect age, or maybe we need to collect something else to really explain what's going on here. But we can explain some stuff here. Education seems to matter. That seems to be moderated somewhat by mobile device use and gender. But yeah, that's how you use dummy variables. Just the one thing to keep in mind, I think, when you're doing this stuff is to always, when you're building your model, right, be careful what you're looking for, and always think about what the expected value of y is given the dummies you're using, right? Because you're switching dummies on, you're switching dummies off, and that changes both the intercept and the slope depending on how this is structured. You could use dummies to modify squared, right? So if you think education has a nonlinear effect, you can take years of education squared or recenter that and square it, and then interact that with mobile device, something like that, and that would allow it to, you know, go up and then tail off or something like that for mobile users or whatever. But yeah, I hope that you found this useful. It's certainly, there's a lot you can do with dummy variables. If you have any questions or would like to see anything more done on this subject, please let me know, and I'll be happy to take a look. And I'm really grateful for you taking the time. Thanks, guys. Bye.